Hello, my name is JBryce and I'm taking EC 311, 331, and 341. And today I'll be covering a power supply management system. As you can see here, we have a generic power supply system that's composed of four parts: V in, the rectifier, the RC circuit, and V out. I will be doing a signals and systems analysis, a microelectronics and circuit analysis, and a little bit of electromagnetics analysis on this system. So let's start off with the input voltage. We're given some sinusoid that is derived in the circuit. And the purpose of that, it could be a sine or cosine wave, but it starts off at 0, goes to some peak value, and in this case it's 1. Then it has a curve back down to the negative peak value, -1, and returns to 0. Now this is done so that way it can alternate between positive and negative values of the system. And you can increase the frequency, you can change the amplitude of it, and that's all done by just adding coefficients here or there. Now, this is done to have an alternating current, basically, where your values alternate between positive and negative half cycles, and that both of these periods are equal and can continue for an indefinite amount of cycles. Now moving on to the rectifier portion, towards the left half of the circuit, we take that voltage in, it goes, or let me back up. There are 4 diodes in the system, and the basic purpose of a diode is to allow the current to flow in the direction of the triangle. It basically doesn't let current flow backwards through it. So now we take that voltage in of the sine curve, it comes in, let's say, for the positive half cycle. So it starts off at V in, it goes up, over, down to the node of diode 1 and diode 4. It passes through diode 1, but not diode 4 because the triangle, the way the diodes are orientated, goes through the circuit, comes back around to where diode 3 and 4 are now, passes through diode 3. Because that is the route to complete the circuit, it will not pass through diode 4, and thus positive half cycle is done. Now the negative half cycle does the opposite. V in goes down to where diodes 2 and 3 are. Again, it flows through diode 2 because it cannot flow through diode 3. Loops around, completes the circuit, goes through diode 3 and 4, however, flows through diode 4, goes around, completes the circuit of the input voltage. Now the purpose of this is to take that alternating current and bring it to a positive only current, so that way your devices can use it. And that is noted by this graph here, where you have your input voltage, which is some sine curve or cosine curve that alternates between positive and negative. However, after it goes through the full wave rectifier, which this system is, the output voltage is the positive only of that sine curve, and the negative values are reflected across the time axis. So regardless of the input values, if it's a negative or positive, the output will always be positive now, which is what this rectifier is in charge of doing. So that way you can get positive curves for the upcoming RC circuit, which we will now talk about. The RC circuit on the right half takes those positive curves, or humps as we can call them, and runs them through 2 resistors and a capacitor. And what these components do is they take the curvature and they flatten it out so that way it's a direct current, or a DC current, or a DC voltage, which is a straight line. And that is done by using the resistor values, which there is a drop across the resistors and a charge built up on the capacitor that eliminates the increase and decrease of the sine curve. As noted here, you can see that the input of the sine curve is now the output is just a straight line at some voltage value. Now that voltage value can be calculated and determined by the resistors you use, the capacitors that you use, what your input is, etc., etc. Now, kind of to summarize all of this, the application of this is to take alternating current or alternating voltage and convert it to DC voltage. Your household outlets are all AC voltages at 110 volts, 60 hertz. So that's your phone can't utilize that. If you wanted to charge your phone, charge your laptop, etc., etc. So with that, your power brick or power cube or charging cube has one, if not a couple, or even sometimes hundreds of these systems that are there to make sure that the voltage it wants is that exact voltage. So it takes the AC voltage, runs through the full wave rectifier, which flips the negative half cycles over to positive half cycles, and then runs it through the RC circuit where it eliminates all the curvature of it and has it become a direct voltage that then your devices can use to power them. And that is a power supply management system.